So here's the first thing I wanted to talk to you about. The init system in the Raspberry Pi. For my projects, I want the init system to be as simple and as straightforward as it should be. But common Linuxes like Raspbian use systemd, which is fine for a full-blown Linux. But for me, it is important that the device is responsive, fast to boot, and does not choke up. So that's why I created npStarter. It is a small init system that replaces a normal init system. It is very, very small, but very, very flexible. You can make it do whatever you want. And this is also very important that you have full control of the system. No strange things will be happening. And also you can modify it to your means very easily. The npStarter init system is quite simple, uses just one file. It sets up the system optionally using wiring. It does all the basic tasks like mounting the main file systems, read-only of course, so nothing bad happens. It probes the system for any device that may be used. It also runs a PHP server for the device to be accessible via net, and does some basic tasks and gets the network up. And this is basically everything it does. All the other tasks are handled in its sub project, which is the np-userland. And for the userland, I've done things in PHP. And basically that's why I do it, because this is the easiest language for me, the most flexible one. I've set up some options you can use, and everything else is done here. And this, you can basically see it's really, really simple. And really simply, I can just set up the system however I want it, you know. So this gives me full flexibility and power I need to create a device that acts as I want it and be fully in control. And also the system is in read-only mode, so the SD card is not in any danger from sudden power loss. So let's check out the main program. This is the synth written in C++. I'll just go over some of the basics. It is quite basic C++. It has some specifics for the Raspberry. I have a very simple main loop. I use a singleton and some audio engine code to get the thing running. I have a separate thread to read and write to the Arduino, only running on the Raspberry. And I load a WAV file and I play it. And this loop just sends the values to Arduino and nothing else, just waits. All the magic happens in here. Here I init the sound system. I use jack audio, and this is the best way to access sound cards on the Linux platform. It works very well. It can be a bit convoluted sometimes, but it's okay. Besides setting up the audio, I also have a nice audio engine here where I process this data. I recently upgraded the audio engine by increasing the data size from long to long, because I'm used to fixed point integer calculations, so I just increased the pipeline because I was using 24-bit audio files. So here is just some oscillator code, some sample positions which I calculate. If it's loop, just go back to beginning. If it's a ping pong loop, okay, ping pong loop is not implemented yet in this version. So this is the code that loads the samples. You can see 8-bit is still not implemented, 16-bit I just implemented, and here's the 24-bit implementation. I shift everything to 32 bits and then I play around with it. I have multiple ways of dealing with the data. This is a more simple way that just puts the output to left and right channel, and that means the first and second channel on the sound card. This is a bit more complex. It pushes all of the sound to all of the sound card outputs. So that means if you have a stereo sound and 8 output sound card, you get like 4 copies of the sound on the output, and its output on all of it just changed by the volume and nothing else. This is a bit more complex operation. It is the sound is moved around based on the sign, and the channels are positioned equally in the physical space, and the sound just moves around you. And there you have like speaker configuration code. If you have speakers configured to be in the specific place, you can just find the distance, and then you can just set the volume by this distance, and the sound comes out depending on its virtual position to the physical speaker. So this is just some code processing this, and the final writing to the jack client. This is all quite simple, and it already works. The next step will be adding a modulation matrix, which is a very fun project of mine I want to do, which is just an input-output matrix that you will be able to set inputs, how much they impact the outputs in a matrix, and basically this will be like setting LFOs to some parameters of the sound or whatever else is on the input. But the interesting part for me will be that for inputs, I mean for the whole matrix, you would be able to take one matrix and morph to another matrix. So basically, if on one matrix you have like 100% LFO to one parameter, on the other you have 50, and then that just smoothly interpolates between them. And also you can just put some more crazy inputs and outputs and add some randomization to the matrices and play with that. So this is a very fun thing I want to do with the synthesizer, and I'm just setting up all the stuff, and you can see yeah, these are the header files. The code is still coming, but this should be fun. The other thing I might do in this iteration of the synth, I might add the touchscreen. I have some drawings of what I wanted to do, but in a way I may even ditch the screen for a more hands-on approach, because the device will also offer MIDI, and that means you can just set up any, you can just connect any keyboard or controller and such, and maybe it will respond to the right default modulation parameters and keys. So basically I'll try to do it without a screen. Maybe later I will add it, because it could be useful. But another way that I find for useful control is to use just a browser. So basically the Raspberry Pi can act as a Wi-Fi point, and you can connect to it and use the browser to connect to the Wi-Fi to the Raspberry Pi, which will then you can control the synth via WebSocket. This is also a fun thing for me, and it makes it very easy to write interfaces, and basically anybody can do it. Just with the right JavaScript file, you can just create your own interface, style it as you want, and it's completely open, and also it can be remotely accessed and multiple devices can be accessed. So it's really an open protocol, which I like very much. So this is the idea, and this is how far I have come